Good day, everyone. Welcome to our new tutorial episode. Today, we're going to tackle or to discuss about the rational zero theorem. Before we proceed to rational zero theorem, I want first to discuss what are rational numbers or the term rational itself. It comes from the word ratio, which means that rational numbers can be formed into a ratio of two numbers. Example of these are 2, 4, 1, 1/2, 1/3, 2/3, and so forth. So as long as the number can be expressed into a fraction, and that is a rational number. Take take note of of 2. This is a whole number, but this number could be expressed in 2 over 1. So this is also a rational number. So there are decimal numbers, for example, 2.5. So this 2.5 is equal to zero point 0.5 is equal to 1/2. So this is 2 and 1/2 or 5 over 2. So even though it is decimal, it is also a rational numbers. So what are not rational numbers? Or we call that thing as irrational numbers. Those are the numbers that we cannot express into fraction. Like square root of 2, like pi, or any other number, square root of 3. So these are irrational numbers. Now let's proceed to what does zero means. Actually, the term roots and zeros, or some it spells as like these zeros, refers to the value of x that would make a polynomial equation or function equal to zero. So zeros of a polynomial is a solution into a polynomial equation. So meaning solution, meaning you have a value of x that would make that polynomial equal to zero. When it roots, it is the value of x. We're talking about the value of x. So zeros for solution and polynomial and roots for the values of x. Okay, for polynomial to be equal to zero. So there's a rule of thumb I found on the other books. It says that when we talk about zero, we're referring to a function. Example, a polynomial function, rational function, and so forth. But if you're going to roots, we're referring to equation. So for discussion, let's just use zero because we're dealing with polynomial function. Okay, so zero in short is the value of x. Now let's go to the definition of the rational zero theorem. The rational zero theorem states that if a polynomial function in this form, standard form, wherein it is written this form, and has an integer coefficient, then every rational zeros of P is of the form of P over Q. So meaning the the values of x in this equation that would make this polynomial function equal to zero is in the form of P over Q. Meaning one of the solution or one of the zeros, we can get that if we divide P over Q. Now what is P? P is the factor of the constant term, which is the last term, or the constant term. And Q is the factor of the leading coefficient. So let's let's put this in action. Again, list down all possible rational zeros. Now, as you can see, there is a term possible. Okay? Because in rational zero theorem, we can use this method to list all the possible rational zeros only. We cannot use this to identify what are the real rational zeros. We are only listing the possibilities of numbers. Because if you're going to find the value of x in this polynomial function, you might end up testing all numbers. So the use of these rational zeros is to limit or to give a specific numbers or numbers to work on in testing if those are the zeros of the polynomial, if those are the values of x that would make this polynomial zero. So let's start with step number one. Step number one is to make sure that the terms of polynomial function are arranged in descending degree of variable x, meaning it should be in standard form. So in this case, we have in descending order 3, 2, 1, and x raised to 0. So our polynomial now is arranged in standard form. Now next is let's define our a sub n or our leading coefficient and our a sub o or our, what do you call this, our constant term. Again, q for the leading coefficient and p for the final term, for the constant term. In this case, in our polynomial, it gives us 3 for our leading coefficient and 2 for our constant term. Now, step number 3 is to list all the factors of p and q. What are the factors of 3? The factors of 3 are 1, positive negative 1, and positive negative 3. Again, to recall, factors are the numbers to multiply to get a certain product. In this case, 3. So what are the numbers that we need to multiply to get the product of 3? And that is positive negative 1 and positive negative 3. Same as with our constant term. So the factors of 2 are positive negative 1 and positive negative. Now, Now, for our final step is we need to solve P over Q because this will give us all the possible zeros of the polynomial function. So we have our P that is 1 positive negative 1 and positive negative 2 over positive negative 1 and positive negative 3. Now let's simplify it one by one. Let's start with positive negative 1. 1 divided by 1 is positive negative 1. And positive negative 2 divided positive negative 1 is positive negative 2. Now let's go with 3. Positive negative 1 divided by positive negative 3, that is positive negative 1/3. Then positive negative 2 divided by positive negative 3, that is positive negative 2/3. So these are all our possible rational zeros. Again, emphasis on possible because this might be the value of x to make this polynomial function equal to 0. So on the later discussion, we will try to eliminate these numbers by using other techniques. But so far, you have 8 choices for the possible values of x. Now, example number 2. How many elements are there in a set of all possible rational zeros of this polynomial function? So this one. So again, we are just tasked to get the number of elements or the number of possible rational zeros. In this case, we're going to find all the possible zeros and we're going to list them down and we're going to count them. This one is easy because it's already in standard form and we have our q as 1. So meaning the factors of 20 would be divided by 1 only. So the factors of 20 is 1, positive negative 1, 2, 4, 5, 10, and 20. So if we solve for p over q, we all just divide this number into positive negative 1. And the answer for that is just that number. Because any number divided by positive negative 1 is that number. So we have that. Now we're going to count them. Remember, each each of these counts as 2 because positive 1 is different from negative 1. So we have 2, 4, 6, 8, 10, and 12. So we have 12 elements or we have 12 possible rational zeros. Let's proceed to our next example. List down all the possible rational zeros of this polynomial function. Again, let's list down the polynomial and list it in standard form. In this case, it's already in standard form. Next is let's identify Q and P. So what the factors of 2 are the following: positive negative 2, and the factors of positive negative 2, positive negative 1. The factors of 10 are positive negative 1, positive negative 2, positive negative 5, positive negative 10. So let's solve for P over Q. Now, as you can see, if we use this one, if we divide all this number into 1, the answer will be that number. So, positive negative 1, positive negative 2, positive negative 5, positive negative 10. So, because if we divide, now let's divide it into 2. 1 divided by 2, that is positive negative 1 half. Then 2 divided by 2, that is 1. We already have 1 in our list, so we don't need to bother writing it again. 5 divided by 2, that is positive negative 5 over 2. And 10 divided by 2, that is 5. Again, 5 is on our list now, so we don't need to write it anymore. So the list of our possible zeros are the following. Positive negative 1, positive negative 2, positive negative 5, positive negative 10, positive negative 1 half, and positive negative 5 over 2. So that's all for this example. Again, remember, we use rational zero theorem to find all the possible rational zeros of the polynomial function, or the possible values of x that would make the polynomial function equal to 0. It doesn't necessarily tell us that all the number that we get are the real zeros are the real rational zeros of the polynomial function. We're just getting the possible values. So that's all for this tutorial. Hopefully that you learned some. I'm hoping that you learned something from this tutorial, and I hope that you learn something from me on the next lesson. So that's all for today. Goodbye and thank you.